All right, I have laid out 12 examples of logarithms and natural logarithms here. Sometimes the best way to get accustomed to them is just seeing plenty of examples and seeing all the little tricks that you might encounter. So let's take a look at some of these, some bit more basic than others, but start with log base 2 of 16. So recall what this really is saying is 2 to some power equals 16, right? Like I read it up and right. Look, start with the base. 2 to some power equals 16. And of course, we could set this up more like an equation and convert it to what we are used to seeing, I guess, textbook method. But, either way, I can look at this and I know the result is 4 because 2 times 2 times 2 times 2, right, to the fourth is 16. So therefore, this answer is 4. And, textbook method, like I was saying, is, let me go ahead and erase 4 really quick. So we say the answer is x. Okay, I don't know what it is, it's x. So the definition, right, by definition of what a logarithm is, we rewrite this as 2 to the x equals 16. And then I could say x equals 4. The reason that's kind of weird is this original problem, all of these, right, none of them have an x. So it's kind of weird to just say x equals 4. Like, what is x? The result is simply 4. Okay, 2 to the 16 is 4. That is our answer. Okay, I hope that makes sense. So this next one, 2 to some power is 40. Well, I don't know, right? Like, what is that? 2 to some power is 40. It doesn't go in evenly because 2 to the fifth is 32. 2 to the sixth is 64. So I know that this has got to be somewhere between 5 and 6, and probably closer to 5 because of the way, right, that 2 to the fifth was 32 and I need 40, where 2 to the sixth was 64. It went up quite a bit. So I had said the only way you could do logarithm in a calculator is either log, which is base 10, or natural log. But there's a trick. Okay, I'll write this up here, and each book kind of uses different variables. That really doesn't matter. So we have the base, lowercase b, right, of m, capital M. I don't know why they use m, just some number. And the change of base formula says to do log, take a new base, a, of m, over log, again, keep that same base, of b. So basically, like looking at this, it says do the log of the big number over log of the little number, right, of the base. That's how I remember it. Now, I wrote log, but you can do natural log as well. In fact, natural log is almost more common as you would progress through math, through algebra. But this still requires a calculator because 10 to what power equals 40, right? And 10 to what power equals 2? I have no idea. So we just used a calculator on this. And we get approximately, I'm just going to round it to 5.32. All right. So there's your change of base formula, but you don't want to rely on it. You really do want to know what a logarithm is, right? Sometimes just easier. So the next one, if there isn't a number there, log automatically assumes a 10. So really what this says is 10 to some power equals 10, right? 10 to some power equals 10. Well, 10 to the 1 is 10. So our result is 1. Now, another reason this is important to point out is if your base and your number you're taking the logarithm of there match, right, if they're the same, you could think of it as canceling out. But why do they cancel? It's because we're taken that base raised to the 1 is that number. Okay. So I'm going to jump slightly over to the right. Remember, ln, this is the equivalent of saying log base e. So e to some power equals e. Again, that is 1. An ln and an e, you could also think of canceling. Remember, when you cancel, it's not 0, right? When I cancel, I get 1. For instance, like 2 over 2. One way to think of that is I could cancel the 2's. I don't get 0, right? 2 over 2 is 1. All right, moving back. Log of 100. Again, log with no base there is assumed to be 10. So 10 to what power equals 100? So 10 squared. Right? So this is 2. Now, if you do either of these in the calculator, because they are base 10, right? Hit log 10, you should get 1. Log 100, you'll get 2. Okay. Moving up top, this is an important one to remember. Log of any base, so any base of 1, is always going to be 0. Now, right, I didn't cancel to get 0. It is 0. So let's look at why. Well, you take any base, right? I chose 4, to what power equals 1. Anything to the 0 is 1. So therefore, our answer is 0. Okay, we did the next one. Again, any base, right? E to the 0 is 1. So ln 1 is 0. And you could verify that in a calculator. In fact, you could hit log 1, right, which would be base 10. You'll still get 0. ln 2. I don't know e to some power, right, equals 2. I have no idea. I need a calculator. I wanted to do this one because, first off, ln is directly in your calculator, so it doesn't require change of base formula. But if you did do the change of base, it would still work. Just know that your base, right, since it's not written, it's a ln. We don't need to write an e there. It's automatically e. But anyways, plug that in your calculator. Verify that you get about 0.6931, so we'll just say about 0.69. Trying to box off the results for all of these, but I keep forgetting. Okay. The next one, again, you could use calculator. Technically, all of these you could use calculator because we have change of base, but you want to avoid it, especially we want exact answers, and sometimes, you know, your calculator, I don't know if I have a example here. No, I don't. That's okay. But, you know, say the exact answer was 3/7, right? Your calculator would give you a decimal answer, and even though you could solve it by hand and you got an exact answer. All right, this one's quite strange. 10 to some power equals 0.001. If I were to read this, this is read as 1/1000th, right? And in fact, we could convert decimals to fractions. This one, you just put 1 over, and then you count the decimal places. That's 1,000. That might be easier to see. Think of it as a fraction rather than a decimal. But still, it's a weird one. So remember that negative exponents brings it to the denominator, right? You create the reciprocal. So on the right, I have 1 over 1,000. I could also think of that as 1 over 10 to the third, right? 1,000 is 10 times 10 times 10. So therefore, this is equivalent to 10 to the negative 3, because the negative brings your exponent, right? You create the reciprocal, and it goes in the denominator. So therefore, the result for log of 0.001 is negative 3. Plug that in your calculator. It'll work because it's base 10. Again, I wanted to do one at first without a change of base, that we could kind of see the idea of how can you do some of these without a calculator? All right, same thing in this one, next one. 2 to some power is 1/4. That's going to be -2 because 2 to the -2 is 1/2 squared, which is 1/4. Right? So therefore, the -2, the exponent, is the answer. So we could do change of base on either of those, like this, the one we just completed in this next one, but again, there's no need. If I rewrote this as log 3, base 3, a fourth root is the same as saying 3 to the 1/4 power. Right? So this says 3 to some power equals 3 to the 1/4. Oops, I don't know why I did a box. Let's just get rid of that. Okay, 3 to some power equals 3 to the 1/4. Well, the only way those could be equal is if the exponents are equal, right? I mean, this box has to be 1/4 in order for those to match. So therefore, this result is 1/4. And if you use the calculator and you got 0.25, I mean, change of base is kind of ugly on this one. Though you are correct, right? Like, looking at this, actually doing the math here gives me 1/4, not 0.25, though they are the same. Okay, and that would be important, like say we had the 7th root, right? 1/7. That is irrational. If you plug that in a calculator and you had a round at some point, that's not exact. Okay, we can do many of these by hand. Don't solely rely on the calculator. All right, the last one I wanted to include, again, because we have an ln and this e. You could almost think of these canceling, but ln and e would be 1. Ln square root e is not 1. We can rewrite e as, square root of e as e to the 1/2 power. So now our answer is 1/2. Again, why? Well, two things. Ln and e, we will learn that they do in fact cancel, and even though this 1/2 is in the exponent, we'll learn properties to get that down from the exponent, and we do in fact get 1/2 as if these canceled. But the other reason, remember, natural log means e to some power equals e to the 1/2. Well, right, the only thing that could be is 1/2. And ln and e cancel. Really quick, if we relate that to above here, I was saying how any base with that number you could kind of think of canceling as well. Notice it did, right? That trick kind of works. Same log base 3 and 3. We got 1/4. But more to come on that when we learn more about properties of logarithms.